Game theory, an introduction. Game theory is a relatively new field of mathematics. Its foundations were laid by the great mathematician John von Neumann. This is about 1903 up to 1957, whose ideas were also valuable in other related fields such as computer science and physics. So let's firstly briefly try to classify and define what stands behind game theory. As Meyerson put it, it is a mathematical language to express models of conflict and cooperation between intelligent rational decision makers. It studies the interaction between decision makers whose decisions interact with each other, which is why Neumann calls to it interactive decision theory. What is often criticized is how game theory models rational behavior, but these assumptions are in the model studied and are not inherent to the mathematical language of game theory. At its inception, game theory was applied to mundane concepts like board games or others. Game theory sees its applications in much broader fields such as economics, even political decision making. So what is a game and what is not a game? An example of non-game would be roulette. The outcome of the game is not dependent on either your decision making nor the decision made by the casino. Your payoff is merely dependent on chance. In contrast, a game like poker could be considered a game since the decision made by each player directly affect the outcome of the game. But the boundary between games and non-games is not always clear. For instance, if an everyday person bought or sold some stocks on the stock market, the effects of your tradings would have a negligible impact on the stock market. However, if big corporations, banks, or nations decide to move currencies, buy stocks or sell shares, their decisions will noticeably affect the situation in the market or. This is when game theory comes into play to analyze what is happening. Prescriptive versus descriptive agenda. Game theory can be used to both reverse engineer the mechanisms of a model or to construct mechanisms to create a most desirable output. Examples of descriptive game theory can be found in biology, social science, economics, computer science, etc. Whereas prescriptive game theory can help us in the field of law, medical research, or macroeconomics. Its impact in economics is extremely outstanding, with over 7 Nobel Prizes given to game theory. Okay. Non-cooperative versus cooperative games. We find that we usually can describe games as being either non-cooperative or cooperative games. What distinguishes the two is the rules in the game. In non-cooperative game theory, the players are individuals and they are unable to write binding contracts with each other. Some key concepts to solving these are the Nash equilibrium or the strong equilibrium. By contrast, cooperative game theory is a formulation of rules where players can be individuals or can merge into large groups of individuals. The groups or coalitions can be formed by binding contract or other forms of leverage. These problems are drastically different from non-cooperative game theory. We use core or the Shapley value to study these problems. And prominent researcher in this field is John Nash, who received a Nobel Prize as well as other prestigious prizes for his outstanding research in non-cooperative game. Okay. The discipline of game theory was pioneered in the early 20th century by mathematician Ernest Zermelo 1913 and John von Neumann 1928. The breakthrough came with John von Neumann and Oscar Morgenstern book. This book is known as the Theory of Games and Economic Behavior. So we can consider this is a foundation book or fundamental book of game theory. This book is published in 1944 during the WW War, Second War. So actually 1 year before the end of the WW War. This was followed by important work by John Nash, 1950 up to 1951, and Lloyd Shapley, 1953. Game theory has a major influence on the development of several branches of economics: industrial organization, international trade, labor economics, macroeconomics, etc. Over time, the impact of game theory extended to other branches of social science, political science, international relations, philosophy, sociology, anthropology, etc., as well as to fields outside the social science such as biology, computer science, logic, etc. The study of economics, political science, and the social sciences more generally is an attempt to understand the ways in which people behave and make decisions as individuals and in group settings. The goal is often to apply our understanding to the analysis of questions to the functioning of societies and their institutions, such as markets, governments, and legal institutions. Social scientists have developed frameworks and rigorous models that abstract from reality with the intent of focusing attention on the crux of the issues at hand, while ignoring details that seems less relevant and more peripheral. We use these models not only to shed light on what we observe, but also to help us predict what we cannot yet see. One of the ultimate goals is to prescribe policy recommendations to the private and public sectors based on the simplistic yet rigorous model that guide our analysis. In this process, we must be mindful of the fact that the strength of our conclusions will depend on the validity of our assumptions, in particular those regarding human behavior and the environment in which people act. Game theory provides a framework based on the construction of rigorous models that describe situations of conflict and cooperation. It's very important to highlight the two sides of game theory, which is based on cooperation and conflict. Between this conflict and cooperation between two rational decision makers. Following the tradition of mainstream decision theory and economics, rational behavior is defined as choosing actions that maximize one's payoff or some form of payoff. subject to the constraints that one faces. This is clearly a caricature of reality, but it is a useful benchmark that in many cases works surprisingly well. Game theory has been successfully applied to many relevant situations, such as business competition, the functioning of markets, political campaigning, jury voting, auction and procurement contracts, and union negotiations, to name just a few. Game theory has also shed light on other disciplines such as evolutionary biology and psychology. So, the discipline of game theory is based on two sides. One of them is to cooperation or conflict. The main consideration here we have to put to pay off. That payoff which is resulting from the situation of cooperation or conflict. So the main question here is to define what is a game. What is a game? Because this technique is based on a game. A game is a mathematical model of a strategic interaction between players. We will be studying a wide variety of games, but all of them will have the following common elements. 1. Players. We often think of players as people, but sometimes they model business, teams, political parties, countries, universities, etc. So, players, we don't mean by players only people. Number 2, choice or choices. Players have to make a choice or multiple choices between different actions. A player's strategy is her rule for choosing actions. Outcomes. When the players are done choosing, an outcome is realized and the game ends. This outcome depends on the choices. Examples of outcomes include player 1 wins, Flora gets $1 and Miles gets $2, or a nuclear war starts and everyone dies. Preferences. Players have preferences over outcomes. For example, Flora may prefer the outcome. Flora gets $2 and Miles gets nothing over the outcome. Miles gets $1 and Flora gets nothing. Miles may have the possible preferences, etc. So the main is that the common elements of the game, players, choices, and outcomes. These are the main features of the game. The components of the game: players, choices, and outcome. Games in the mathematical sense are defined as a strategic situation in which there are multiple participants. Furthermore, the outcome of the decision any individual makes is dependent on the decision, that individual decision, and the decision made by all of the other participants. Based on above mentioned elements of the game, we can define also game theory as a study of mathematical models, again, of strategic interactions. It has applications in many fields of social science and is used extensively in economics, logic, system science, and computer science. Initially, game theory addressed two-person zero-sum games in which participants' gains or losses are exactly balanced by the losses and gains of the other participants. So it is now an umbrella term of the science of rational decision making in humans, animals, and computers. Modern game theory begins with the idea of mixed strategy, equilibria in two-person zero-sum games, and is proved by John von Neumann. As we mentioned before, game theory was developed extensively in the 1950s and was explicitly applied to evolution in 1970s. Also, similar development go back at least as far as 1930. Game theory has been widely recognized as an important tool in many fields. Two important features make a game strategic. So here I would like to distinguish between non-strategic game and a strategic game. So the main question here is how to define that game is a strategic game. Let's select the facts. First, the fact that outcomes are determined by everyone's action rather by the action of just one player. So, more than one player. So, this is fact number one. The outcomes are determined by everyone's actions rather than by the actions of just one player. One player, that is not a game. Game must be by more than one player, more than one participant. Okay. Second, that players have different preferences. That's correct. This creates tension which make games interesting. No, timing. Do players choose once, rock, paper, scissors, or again and again over time? In the latter case, does the game eventually end or does it continue forever? Does they choose simultaneously or in turn? That's the game. So the game must be subject to timing, the determination of time. Observation. Can players observe each other's choices? Main question. And certainty. Is the outcome random, or is it a deterministic function, or the player's action of the player's action? Do some players have information that the others do nothing? Games differ in many aspects. In many aspects. So here I would like to make stress on two main facts. Outcomes are determined by everyone's actions. Secondly, the players have different preferences. According to mention two factors, so the game have the following elements: timing. The game must be timed, observed, and determined by in sense of certainty or uncertainty. It is important to note that a game does not specify what the players actually do. But only what their options are and what the consequences are. Okay, so the function of a game is not to specify what players actually do. The game doesn't focus on what the tasks of players, but only what their options and what the consequences resulting from choosing the options. Okay, this is the main. Unlike an equation which maybe has a unique solution, the answer in games is much less clear cut. A solution concept is a way to think about what the players might decide to do. It is not part of the descriptions of the game. And different solution concepts can yield different predictions for the same game. Many decisions are taken in a competitive situation in which the outcomes depend not on decisions alone, but rather on the interaction between the decision maker and that of a competitor. The term games now not includes pleasurable activities of this kind, but also much more earned competitive situation of war and peace. Okay. It is not coincidental that the classic work on the theory of games was first published during the Second World War. Many competitive situations are still too complex for the theory in its present state of development to solve. Other methods, of which war games are long established examples, and business games of more recent origins have been used. The availability of the computers has allowed increasingly large-scale operations to be represented with great realism. Alongside the theory of the games has been represented with great realism. The theory of the games has been developed alongside gaming techniques and a knowledge of the concepts involved, especially the importance of role of chance, helps clarify the issues in many decision making process. So here I would like to emphasize that many decisions are taken in a competitive situation in which the outcomes depends not on decision only, but on the interactions between the decision maker and that of a competitor. That is the most important to be noted. Okay, let, let us introduce with the main terminologies of game theory. Repeatedly, game is a competitive situation is called as a game if it has the following properties. So, when we can call game as a game, so the game must satisfy the following properties. Number one, there are finite number of participants called players. Okay. Determined number of participants called players. Each player has finite number of strategies available to him. Okay. Every game results in an outcome. Every game result is an outcome. These are the main characteristics of the game. First, there are finite number of participants or players. Each player has restricted number of strategies available to him. Every game results in outcome. Number of players. If a game involves only two players, competitors, then it's called a two-person game. However, if the number of players is more than two, the game is known as n-person game. N maybe 3, 4, 5, etc. Sum of gains and losses. If in a game the gain of one player are exactly the losses to another player, such that sum of the gains and losses equals 0 or equals to 0, then the game is said to be a zero-sum game. Otherwise, it is said to be non-zero-sum game. Okay. Let's move to the second slide. Basic. Let's continue the introduction of the basic terminologies. Strategy. The strategy for a player is a list of all possible actions that he will take for every payoff or outcome that might arise. This is the meaning of strategy. Strategy means a possible list of possible actions for a player. it is assumed that the rules governing the choices are known in advance to the player. So these strategies are assumed to be known in advance to a prior to the players. So every player knows what is his actions in advance, of course. So the outcome resulting from a particular choice is also known to the player in advance and expressed in terms of numerical values. Here it is not necessary the players have a definite information about each other strategy. Okay. So here the outcomes are known in advance. The strategies are known in advance. So let's classify the forms of strategy. Optimal strategy. Optimal strategy, it means the particular strategy by which a player optimizes his gains or losses without knowing the competitor's strategy is called optimal strategy. So the main characteristic of the optimal strategy that a player optimizes his gains, optimization, optimizes his gains or losses without knowing the competitor strategies. This is the definition of optimal strategy. Value of the game is the expected outcome per play when players follow their optimal strategy is called the value of the game. The value of the game is very significant value in game theory, especially when we use saddle point. Number 2 is pure strategy. It is a decision rule which is always used by the player to select particular course of action. Thus, each player knows in advance of all the strategies out of which he always select only one particular strategy, irrespective of the strategy of other players. The objective of the players to maximize gains or minimize losses. So the pure strategy means the player select particular course of action regardless the choice of other strategy. This is what do we mean by pure strategy. Now we introduce with two forms of strategy: optimal strategy and pure strategy. Let us introduce with the remains form of strategy in the next slide. Mixed strategy. When both players are guessing as to which course of action is to be selected on a particular occasion with some fixed probability, is known as the mixed strategic game. Thus, there is a probabilistic situation. An objective of the players is to maximize the expected gains or to minimize expected losses by making a solution among pure strategies with the fixed probabilities. Two-person zero-sum game. A game with only two persons is said to be two-person zero-sum game if the gain of one player is equal to the loss of the other. This is known as two-person zero game. Payoff matrix. The payoffs in terms of gain or less losses. When players selected their particular strategies can be represented in form of a matrix called the payoff matrix. If the game is zero-sum, the gain of one player is equal to the loss of the other player and vice versa. In other words, one player's payoff table will contain the same amounts in payoff table of the other player with the sign change. So this what do we mean by the basic terminology: optimal strategy, mixed strategy, and pure strategy. Later we will introduce you with the main forms or methods of game theory. Beside two-person zero-sum game, there are various forms of games. Games classification or types of games. Games can be classified according to certain significant features, the most obvious of which is the number of players. Thus, a game can be designated as being a one-person, two-person, or n-person with n greater than 2 game. Games in each category having their own distinctive features. One-person games also are known as games against nature, with no opponents. The player only needs to list available options and then choose the optimal outcome. When chance is involved, the game might seem to be more complicated, but in principle the decision is still relatively simple. For example, a person deciding whether to carry an umbrella. So this is about one-person game. Two-person zero-sum game with two players. The game in which there are exactly two players and the interest of the players completely opposite, as referred as two-persons zero-sum game. They are called zero-sum games because one player wins whatever the other player loses. In short, it is denoted by TPZS. So TPZS stands for, it is an abbreviation of two-person zero-sum game. Continue. Two-person zero-sum game with more than two players. TPZS games with more than two people involved are, for example, team sport with only two sides but with more than one player in each side. This is example. Football team, for example. Many people involved in surrogates for military conflict. So it should come as no surprise that many military problems can be analyzed as TPZS games. Games which are not TPZS. Those parallel games in which the players cannot be clearly separated into two sides are not TPZS games. Those poker and Monopoly games, when played by more than two people, are not TPZ games. Most real economic games are not DBZS because there are too many players, and also the interests of the players are not completely opposed. Let's continue the types of game. Positive sum game. Its characteristics of games. In game theory, a term positive sum refers to situations in which the total of gains and losses is greater than zero. This is known as positive sum game. A positive sum occurs when resources are somehow increased and an approach is formulated such that the desires and needs of all concerned are satisfied. Perfect games. Games of perfect information in which each player knows everything about the game at all times. It is called perfect games. Imperfect games. Games of imperfect information in which each player do not knows everything about the game at all times. It is called imperfect games. Finish games. Games in which each player has a finite number of options. The number of players is finite, and the game cannot go on indefinitely. Cooperative games. In game theory, a cooperative game or co-alliational games is a game with competition between groups of players, coalitions, due to the possibility of external enforcement of cooperative behavior. Non-cooperative games. Those are opposed to cooperative games in which there is no possibility to form alliances, or all agreements need to be self-enforcing. Here we face positive sum game, perfect games, imperfect games, cooperative games, and non-cooperative games. Basic assumptions of game. Each player has available to him a finite number of possible strategies. The list may not be same for each player. Player A attempts to maximize gains and player B to minimize losses. The decisions of both players are made individually prior to the play with no communication between them. The decisions are made simultaneously and also announced simultaneously so that neither player has an advantage resulting from direct knowledge of the other player's decisions. Both the players know not only possible payoffs to themselves but also others. So these are 5 basic assumptions of game. Each player has finite number of possible strategy. Player A attempts to maximize gains while player B to minimize losses. The decisions of both players are made individually prior to the play. The decisions are made simultaneously. Both the players know not only possible payoffs to themselves but also to others. Methods of game theory, or the techniques of game theory. Two-person zero-sum game, saddle point, domination with pure strategy, domination with mixed strategy, averaging, Oxford game theory, M2 and 2N game theory, subgames, graphical method, Nash equilibrium, prisoners. We will not cover all these methods, but we will try to focus on the main of them. Two-person zero-sum game. Basic assumption of the game. Each person has available to him a finite number of possible courses of action. The list must not be same for each player. Player A attempts to maximize gains and player B to minimize losses. The decisions of both players are made individually prior to the play with no communications between them. The decisions are made simultaneously so neither player has an advantage resulting from direct knowledge of the other player's decision. Both players know not only the possible payoffs to themselves but also of each other. Minimax Max-Min principle. The selection of an optimal strategy by each player Without the knowledge of competitors' strategy is the basic problem of playing games. The objective of the study is to know how these players select their respective strategy so that they may optimize their payoff. Such a decision-making criterion is referred to as the minimax-maximum principle. So this is the definition of minimax-maximum principle. Remarks: minimax-maximum principle, given the best possible selection of strategy for both players in pure strategy problem. Saddle point: if the minimax value equal maximum value, if the minimax value equal maximum value, then the game is said to have a saddle equilibrium point. Okay. This is a condition of how to describe the game as a saddle point game, or the game has a saddle point. The condition is the minimax value should equal the maximum value. Saddle point. Saddle point is based on minimax and maximum principle. So, to define this principle, consider the pay matrix of a game which represents payoff of player A. Now the objective of the study is to know how these players must select respective strategies so that they may optimize their payoff. For player A, minimum value of each row represents the least gain to him if he chooses his particular strategy. These are written in the matrix by row minimum. He will select the strategy that gives him largest gain among the row minimum value. The choice of player A is called maximum principle, and the corresponding gain is called outcome. Now let's see how to follow the procedures of determining saddle point. First step, select the minimum lowest elements in each row of the payoff matrix and write them under the row minimum heading. Then select the largest element among these elements and enclose it in a rectangle. So just look to each row and select from each row the lowest element and state it in front of each row. Then select the maximum element from these minimums. So we call it max min. Step 2, let's go to the max min. That is minimax and this is max min. Here in the minimum, the lowest elements in each row, and then select the largest element among these elements of and enclose it in a rectangle. Step 2, select the maximum largest element in each column of the payoff matrix and write them under column maxima heading. Then select the lowest elements among these elements and enclose it in circle. These are two procedures. Let's go to the third procedure. Third step number 3, find out the element which is the same in circle as well as rectangle, and mark the position of such element in the matrix. This element represents the value of the game and is called the saddle point. Last station, game without saddle point. Suppose if there is no pure strategy solution for a game, then there is no saddle point exist. In these situations, to solve the game, both the player must determine the optimal mixtures of strategy to find saddle point. The optimum strategy mixture of each player may be determined by assigning each strategy its probability of being chosen. The optimal strategy so determined is called mixed strategy. So now, if there is no saddle point, we will choose mixed strategy instead of saddle point. So there are 3 steps to follow for solving the game theory by the saddle point. Okay, this is the first example of saddle point. Please pay attention. This table of matrix contains 6 cells. Each square represents 1 cell. For example, the square where is -3 is called cell. Okay, the square where is -2 also is called cell. The square where is number 3 also is called cell. There are 2 players, player A and player B. The participants in this game are 2, player A on the left side and player B on the upper side. Okay. Player A deals with row and he is known as a maximum player. So he plays for maximum. So this table consists of 3 rows: row 1, row 2 and row 3. These rows can be called also strategy. So player A, once he has 3 rows, that means he has 3 strategies. Each row represent 1 strategy. From other hand, there are 2 columns only. Player B deals with column and he is a minimum player. He plays to minimize losses. Player A plays to maximize gains. Now, this is a general picture. Player A faces 2 rows, that means he has faces 3 rows, that means he has 3 strategies, while player B has 2 columns, that means he has 2 strategies. Okay, now we would like to play a saddle point game. The steps of saddle point or to find saddle point are followed. Just look to the rows. Here we are going to apply the minimum of row. Look to each row and select the least number, okay, or the less payoff or the less outcome. The first row, there are 2 values, -3 and 6. Logically, -3 is less than 6, and we are going to write -3 less than -6. Move to the next row. There are 2 values, -2 and 4. -2 also is less than 4. The last row has 2 values also, 2 and 3. 2 is less than 3. So the minimum of all these rows are 3 values, -3, -2 and 2. These values are known as minimum of row. These three values are known as minimum of row. Now we are going to select the maximum of these minimums. The maximum of these minimums are 2, because 2 is more than minus 2 and 2 is more than minus 3. So the maximum of the minimum, or the max min, is 2. Okay, now let us move to deal with player B. We mentioned before that player B has 2 columns, respectively has 2 strategies. Now we are going to apply the principle of maximum of column. Maximum of column. In this case, we are going to select the maximum of columns. Okay. Also, column 1 had 3 values: minus 3, minus 2 and 2. So the maximum of column 1 is 2. 2 more than minus 2 more than minus 3. Okay. Moving to column 2, we found that 6 more than 4 and more than 3. This is the maximum of column. So the maximum of column are 2 values, 2 and 6. Now we are going to select the minimum of those maximum. Between 2 and 6, the minimum is 2. Okay. The common values between minimum of row and maximum of column is 2. 2 is the minimum value of the minimum of row and the maximum of column. So let's go to the table and to search where is the number 2 or value of 2, where the place of the value of 2. Okay, the value of 2 is in the third row of player A and the first column of player B. Okay, so this value of 2 is known as game value. Game value is the common value between player B and player A, or the common value between the minimum of row and the maximum of column. So the saddle point is row 3 and column 1. Then the point is 3, 1. Optimal strategy for player A. So he is going to choose row 3 because the place of his value is in row 3. So for strategy for row 1, he has no strategy. Then we write 0. In the row 2, he has no strategy. Then also are going to write 0. In the third row, he has strategy. Then we are going to write 1. 1 means he has strategy. So the optimal strategy for player P is in row 3. Let's move to the player P. The value to place is under the column 1. Then the optimal strategy, he has 2 strategy only, player P. The optimal strategy for player B is to choose column 1. That means we are going to write 1. In the second column, he has no strategy. Then we are going to write 0. Okay? That's all. Okay. Referring to the example 1, I would like to remark the following. Player A had 3 strategies because of 3 rows. Player A gained 6 points. The preference of player A due to his strategy is more than strategies of player B. Player B has 2 strategies because of 2 columns, and he loses 6 points due to his strategies compared to player A. The condition of saddle point is maximum equal minimax, and if so, the cell of corresponding row and column meet is called saddle point, and the value in the cell is called game value. Saddle point is a cell location. It is not value. Okay, saddle point 2. Given the matrix of outcomes for player A and player B, as you see, in this case, player A had 3 rows. Respectively, he has 3 strategies. Also, player A had 3 columns, and respectively he gets 3 strategies. Again, player A plays for maximum. That's why he is a maximum player. Player B plays for minimum. That's why he is a minimum player. Now, we are going to follow his steps in determining the minimum of row and the maximum of column. Again, let me remind you about the condition of the saddle point. The saddle point is satisfied if the minimax equal the max min. This is the condition of saddle point. Each cell, let's calculate them. We have, this matrix shows 9 squares or 9 cells. Each cell contains of one outcome: -3, 0, 4, 1, 7, 2, -6, 5, -9. These are outcomes. Now, step 1 is to apply the minimum of row. There are 3 minimum of rows. Now, for row 1, the minimum value is -3, because -3 is less than 0 and less than 4. For row 2, the minimum value is 1, because 1 is less than 7 and less than 2. For the third row, row number 3, the minimum value is -9, because -9 is less than 5 and less than -6. The minimum of row thus are -3, 1 and -9. Now, the maximum of the mentioned minimums are 1, because 1 is more than -3 and it is more than -9. Now, moving to the operation of columns. The maximum value of column 1 is 1. Move to column 2, the maximum value is 7. 7 more than 0 and more than 5. And the last column shows that the maximum value is 4, because 4 is more than 2 and more than -9. So, the maximum of column are 1, 7 and 4. The minimax, the minimum of all those maximums are 1. 1 is less than 7 and less than 4. So, now the common value between the minimum of the row and the maximum of column are 1. So, this is known as the game value. The place of 1 is the intersection point between row 2 and column 1. So, look to the circle. So, value 1 is the intersection point, the place of value 1 is the intersection point of row 2 and column 1 respectively. The saddle point is 2 here stands for the row, and 1 here stands for column. Now, so the determination of the saddle point depends on the game value. If there is no game value, we could not determine the saddle point. So the determination of the game value depending upon the finding of game value. Okay. Now we are going to forecast the optimal strategy for players. Look, the place of the game value is row 1 and row 2 and column 1. So player A is going to choose strategy number 2. Where the place of row 2. So player A is going to choose strategy 2. So he will not care about strategy 1 and strategy 3 or row 1 or row 3. That's why his strategy for row 1 equal 0. For row 2 equal 1. For row 3 equal 0 because he has no strategy in the row 1 and row 3. Let's move to player B. Player B, he will not going to choose strategy 2 or strategy 3 because according to the saddle point, he is controlled by the saddle point. His strategy is controlled by the saddle point, and the place of the saddle point is column 1. That's why he is going to choose strategy 1. The others will remain equal 0. That's why for player B, strategy is 1, 0, 0. Again, 1 here means a compiled strategy, optimal strategy, not the number, strategy number 1. No. That means he has a strategy. Here means 1, he has strategy. There is no strategy means equal 0. D'accord? So 1 does not direct the number of strategy. No. If there is a strategy, we write 1. If there is no strategy, we write 0. Okay? Saddle point 3. Each player has 4 strategies because of the 4 rows and 4 columns. Now let's check the minimum of row. First, row number 1, the minimum value is negative 9. For row 2, the minimum value is 2. For row 3, the minimum value is 7. For row 4, the minimum value is 1. So, the maximum of these minimums is 7. 7 is more than negative 9, is more than 2, and it is more than 1. Let's move to the columns. The maximum of column are, for first column is 12, for column 2 is 11, for column 3 is 8, for column 4 is 3, no 10, sorry. Now the minimax, so the minimum of all these maximus is 8. Oh wow, there is no common value between the maximin and the minimax. Maximin is 7. No, maximin is 7 and minimax is 8. Remember, the condition of the saddle point is maximin must equal minimax. So maximin does not equal minimax, then it has no saddle point, but it has game value, which can obtain using other methods. Okay. Saddle point 4. Surprise. Okay. 5 strategies for player B and 4 strategies for player A, because player A has 4 rows while player B has 5 columns. Okay, the outcomes equal 20, 4 columns multiply times 5 columns times 4 rows equal 20. Now, or actually 20 cells. Now, looking at the right side of the matrix, we added 1 column to calculate the minimum of row, and we add the lower column here, the lower row to calculate the maximum of column. Now, for row 1, the minimum value is negative 2. The minimum value is negative 2. Negative 2 is less than 12, 3, 6, and 15. For row 2, the minimum value is 6. For row 3, the minimum value is 2, and for row 4, the minimum value is 0. Okay. While the maximum of columns are 9, 10, 6, 10, and 13. 9 is more than 2, should be 15. 15 is more than 9, more than 2, more than 8. 10 is more than 9, more than 8, more than 6. And 6 is more than 3, more than 4. And 10 is more than 8. 12 is more than 8, more than 2, more than 10. And 13 is more than 0, more than 11, more than negative 2. The maximum of row is 6. The maximum of row is 6. And the minimax, the minimum of the maximum is 6. So here max min equal 6 equal minimax equal 6. So the game value is 6. The place of the game, check 6 inside the circle. Inside the circle, the place of 6 is row 2 and column 3. Row 2 and column 3. Is saddle point equal 2. 2 stands for row 2 and 3 stands for column 3. The optimal strategy according to the saddle point, player A will choose the strategy number 2, and he will neglect strategy number 1, number 3, and number 4. Then for player A, 0, 1, 0, 0. For player B, according to the saddle point, he will choose strategy number 3. Then he will neglect strategy number 1, number 2, number 4, and number 5. So his optimal strategy is 0, 0, 1, 0, 0. Okay. Saddle point 3, 2 players. Player A has 4 strategies, as well as player B has 4 strategies, because each of them had 3 rows, or 4 rows or 4 columns. Now, as usual, firstly, let us apply the minimum of row. For first row, the minimum value is 1. In the second row, the minimum value is 2. For third row, the minimum value is 4. For row number 3, the minimum value is 3. So, the maximum of these minimums are 4. Moving to the operation of columns. The maximum of the first column is 7. Of the next column is 4. Of the third column is 5. And last column shows 8 as the maximum value. The big or maximum value between these minimums are 4. And the minimum or least value of these maximums is 4. So the common value between the minimum of row and the maximum of column is 4. So the game value, if the common value between minimum of row and maximum of column, which is 4. Thus, the game value equal 4. The game value is the intersection value between column 2 and row 3. The places 4 is between row 3 and column 2. Therefore, 3, 2 is said to be saddle point. Accordingly, we are going to determine or to forecast the strategy of each player. Player A, of course, will choose the third strategy, or row 3. Then his optimal strategy, it looks like 0, 0, 1, 0. And for player B will choose strategy number 2, and he will neglect strategy number 1, 3, 4. Then his optimal strategy, it looks like 0, 1, 0, 0. So game value is 4, saddle point 3, 2. Please, 3 stands for row. Remember that for saddle point we write first row and next column. That's why 3, 2, not 2, 3, 3, 2. Okay, that's all. Okay, saddle point 7, 6. Given two players, player A had 3 rows, respectively 3 strategies. Player B has 4 columns, respectively 4 strategies. The quantity of strategies or the number of strategy depends on the numbers of columns or rows. If there are 3 rows, that means 3 strategies. If 4 rows, 4 strategies for player A. If there are 5 columns, that means player B has 5 strategies. If there are 2 columns, that means player B has 2 strategies. As usual, we are going to apply the minimum of row and select the least value of each row. 2 is the least value of row 1, negative 6 is the least value of row 2, and negative 2 is the least value of row 3. The maximum of these 3 values are 2, cos 2 more than negative 6 more than negative 2. Looking to the column, the maximum of column 2 is the maximum, more than 1. 7 is more than negative 6, more than 4. 5 is more than negative 2, more than negative 4. And 5 is also more than negative 3, more than 1. Max min equal to minimax equal to. That means game value equal to saddle point, the place of 2 is so here max min equal to and minimax equal to, then game value equal to, and the place of this game value is the intersection point between column 1 and row 3. We will guess that player A will choose strategy 3 while player B will choose strategy 1. Okay, so player A the optimal strategy for player A is 0-0-1, because he has no strategy on for he has no strategy 1, he has no strategy 2, he has strategy 3. That's why 0-0-1. For player B will choose strategy number 1. The remains must equal 0-0-0. So 1-0-0-0. So the point 7, player A has 3 strategies, player B has 4 strategies. Applying minimum of row minus 30 for row 1, minus 25 for row 2, minus 40 for row 3, maximum of column shows that the maximum of first column is negative 25, and the maximum of column number 2 is negative 20, the maximum of column 3 is 50, and the maximum of column 4 is negative 10. The minimax, the minimum of all of these maximas, is negative 25. The common value between maximin and minimax is negative 25. Therefore, the game value equal negative 25. The place of negative 25 is in the intersection cell or intersection point between column 1, between row 2 and column 1 respectively. The saddle point is 2, 1. 2, as mentioned before, stands for row 2 and 1 stands for column 1. Then the optimal strategy for player A is 0. He will not choose strategy number 1. 1, of course, 0 and 0. 0 for strategy 1, 0 for strategy 3, and that's all. For player B, he will choose strategy number 1. That's 1 equal 1, 0, 0, 0, because he has 4 strategies. For player A has 3 strategies. Okay, that's all. Last of the point, player A has 4 strategies, player B has 4 strategies. Applying the minimum of row, negative 1, negative 4, 0, negative 3. The minimum of the maximum of all these minimums equals 0, and let's applying the maximum of column. First column, the maximum is 7, second 12, third 9, fourth is 7. So the maximum, the minimax equals 7 and maximum equal 0. So the condition of the saddle point is disappeared. So in this case we couldn't apply the saddle point, or there is no saddle point because there is no game value. Actually, there is no common value between minimax and max min. Max min equal 0 and minimax equal 7. That's why we in this case there is no saddle point. The condition of the saddle point is that minimax must equal max min. Minimax must equal max min. So if minimax doesn't equal max min, so there is no game value. If there is no game value, respectively, we can't determine the saddle point. Saddle point 10. Please try to solve these two exercises. Exercise 1. There are two players, of course, as usual, player A, player B. Player A has 4 strategies, player B has 4 strategies. The second exercise, player A has 4 strategies. Player A has 3 strategies, while player B has 4 strategies. Try to find the saddle point. Thank you.